equivalence point, pH equals pKa. Oops, that's supposed to be an H. Okay. All right. In terms of the indicators, I made this little diagram to make it easier. Okay, so if we look here, and guys, I would say that indicators change maybe like plus or minus 1, right? So if it has a pKa of 11, then it's going to change from 10 to 12. If it has a pKa or pH, I mean, these are measuring kind of the middle part. So if you look at the graph, okay, there. All right, this is where everything's going to change. Methyl red's going to change here. Does that work? No, it's not on the rise. Does this one work? Bromothiamyl blue is going to change too early. Will this one, will the thiamyl blue work? Yeah, it changes on the vertical rise. So number 3 is a contender. How about the thymylphthalate? Is that on the rise? It's from here to here, so it's mostly on the rise. That'll work. Okay, what's wrong with alizarin?
It's on the curve.
It's just on the curve, a little bit too high. So that's why the answer was G, 3 or 4. Does everybody get that?
Mm-hmm.
Okay. All right. So now the species, okay? If we look down here, all right, what species is most present? All right, I'm actually going to flip to the camera so we can talk about that. All right. And I actually have, is the key over here? Yes. I've got a lot of this written already. Okay. So if we look here at the key, all right, before you've added any NaOH, all you have is HA, right?
Mm-hmm.
So I think number 15 is self-explanatory, okay? After you add 10 mils, do you see how we're not even halfway when we add 10 mils? So, do we have any HA left? Yes, we certainly have HA, okay? Do we have any A minus that we've produced? Absolutely, okay? Do we have any spectator ion, which is sodium? Oh, yeah. Do we have any hydroxide? No, because every time we have HA and NaOH, right, we have a lot of this and a little of this when we're only at 10 mils. So all the OH is going to go bye-bye, right? So all we're going to end up with is a little bit of HA left, some A minus, some sodium unreacted, and so that's not in there at all. Tell me about H plus. No, we don't have any H plus. This isn't a strong acid. We're never going to have H plus. That's out. Okay? So the answer is 1, 3, and 4. That's why the answer was D. Okay? At the equivalence point. At the equivalence point, what have we totally neutralized? The acid. Guess what? It's gone. And H plus we said is never there. Tell me about the OH. Not there. Okay? So all we have left are those. Okay? That is the result of neutralization. So that's why the answer was C. Number 18 was kind of tricky. Okay? Let me focus this a little bit better. There. Okay? Guys, after 30, 30 is beyond the equivalence point. So we're going to have some excess NaOH, right? Mm-hmm. But let me ask you this. Are we going to have any HA and any H plus? No. So actually, at that point, these values are 0. Okay? So they're going to be the least of all. Okay? They're equal to each other because they're 0. Okay? Now, this is what trips people up. Okay? Let me kind of show you a picture. All right? So let's say before we titrate, we had 2 HAs. At the equivalence point, haven't we neutralized each of those? Yes. And so we've made A minus, H2O, Na plus, and remember the OH kind of combined with the H to make the water. So we don't have any excess OH at the equivalence point. Does everybody get that? So at the equivalence point, that's this, all we have are these things. So after the equivalence point, not only do we have these things, but now we have some extra Na and OH. So which ion is the most abundant? Na. Everybody thinks OH, But remember, all the beginning amounts of OH that you added were busy neutralizing the H in the HA. So we don't have an OH for every Na that's there. So Na ends up being the most abundant. That's the only answer choice that had it. And then your second most abundant, if we're not adding a huge excess of NaOH, is going to be A minus. And then we have a little bit of the OH, and then we don't have any of those. Does that make sense? Okay. All right. On the back.